Hi there folks, this is the Unit 11 review, and as always I am the amazing Mr. Jansen, so away we go. If we look at the first one, this is a parabola, and I want to graph this thing in terms of the vertex, focus, axis, symmetry, directrix, and the direction movement is kind of going to take care of itself. When I graph this thing, I'm going to do it the same way I've always graphed these. I'm basically going to do this based off of the vertex and axis symmetry. The focus is going to kind of graph itself, and then I'll write down what it is. So let's start with the vertex. When it's in standard form like this, the vertex is always the opposite of b over 2a. So do opposite of b over 2a. So that's going to be a 2 over 2 times a negative 1/8. Now it's just a matter of simplifying this. That's 2 over a negative 1/4, which is going to give me a negative 8. Alright, since this thing is x equals and the y is squared, alright, this means this thing is going to be a horizontal parabola. So since this thing is going to be horizontal, it means that when I do opposite of b over 2a, instead of giving the x value, it gives me the y value for my vertex. That's my y value. And now I plug that in for y, so I plug it in here for y. Each place I see a y, I'm going to replace it with that negative 8. And I plug that in, and that gives me a positive 9. Alright? And so now from here, the axis of symmetry, normally it's x equals the x value from the vertex, but because this is horizontal, it's going to be y equals the y value from the vertex. Okay, so everything I used to do for x and now do for y, everything I used to do for y and now do for x. And now from here, I'm going to graph this thing. So I go ahead and graph. My graph is not quite big enough, so I'm going to rescale this thing. So I'm going to go by 2's over here. I'm going to put little marks in between. So if I want to go to 9, negative 8, so let's see, 9, negative 8, it's going to be right here, okay? So that's my vertex. From here, I can finish graphing this thing. My axis of symmetry is right here, y equals, so it's a horizontal line. One of the other points that I have here, right here, this guy is normally my y-intercept. Because this is horizontal, that's my x-intercept. So I can plot that as well. I could even reflect that point to give me a little bit more in terms of this thing. But I can see my parabola looks kind of like this. Alright, so I get this wide parabola that opens to the left. And it makes sense that it opens to the left because right here, the a value is negative, which means I'm going to open to the left. So now I've got the direction of opening already. And now from here, the focus and directrix, I just need the focal length. Remember, the focal length is the 1 over 4a. So I do 1 over 4 times a negative 1/8. And when I do that, it kind of spits out a negative 2 if I do this correctly. And so what that's telling me is that the focus is 2 units away in the negative direction. So I basically count 2 units to the left. 1, 2, and I put a point. That's my focus. All right, and I can write down the ordered pairs for that point as well. It looks like the ordered pairs here are going to be a 7, negative 8. Going in the other direction, if I go 2 in the other direction, it brings me to my directrix. So if I go 2 this way and draw a dotted line, this one's going to be a vertical line. That's my directrix. And I can come over here and say, okay, that's the line x equals 11. All right, and that's it. So again, the graph kind of takes care of itself, and then we fill in the focus and directrix based on how far away they are. So I find the focal length and I count to find the focal point and the directrix. Okay. If I look at the next one, this one is a circle. Remember, circles are of the form x minus h squared plus y minus k squared equals r squared. So it's kind of like I take the opposite of each of these. So the x value for my center is a negative 4. The y value is a positive 1. And then right here, this is r squared, so the r value is the square root of that, so r equals 3. And now from here, I plot the center, so negative 4, 1. And now I just count 3 in every direction that I can count, so up, down, left, and right. And now I just draw the best circle that I can, all right? So I try to draw something that looks kind of like a circle here. I do my best, and if it's a little off, that's okay. Mine's not great this time, but we can tell that it looks like a circle, all right, or it's supposed to look like a circle, okay? If I look at the next one is an ellipse, and I can tell it's an ellipse because of the format that this is in with these big fractions, and the fact that there's a plus sign in between is the giveaway for this thing to be an ellipse. So the center, remember the x value is with x and the y value is with y. So right here, the x value is over here, the y value is over here with y. So it's kind of is reversed of what we would normally think here, but the x value here is a 1 and the y value is a 3. And again, we still take the opposite of those just like we do anytime we're pulling things out of those parentheses. All right. The first fraction has a squared underneath it, so the a value is the square root of that. It's a 4, and that's just the same thing that we did in terms of the radius of our circle. The b squared is 4, so b is a 2. And now from here, again, I'm not going to plot these foci until after I go ahead and graph the ellipse. So I'm going to graph the ellipse. So 1, 3, puts my center right here. You'll notice that y is associated with the a squared, so that means the a value is going to count up and down. So I go up and down 4, so up 4 and down 4. The b value is underneath the x, so the b value is going to go left and right, so I go left and right 2 units. And now I just draw the best ellipse that I can. And again, mine's not perfect. But we're kind of rushing a little bit here. But anyway, so the c value is the thing that's going to give me the two focal points here. And the equation for the c value is a squared minus b squared equals c squared. So we've got 16 minus 4 equals c squared. So I find out that c squared equals a 12. So I take the square root of each side, and I find out that c equals plus or minus the 3.5. And the only reason it comes out as plus or minus is because it's telling me to count in 2 different directions. I'm going to count the c value the same way I did the a and the b values, and I'm going to follow the same direction as a. So I'm going to count up 3.5 and put a point, and I'm going to count down 3.5 and put a point. And those are my focal points. I just have to label what ordered pairs I just plotted. The first one that I plotted looked like 1 comma 6.5, and the next one I just plotted was 1 comma negative 0.5, and that's it. All right, so again, we use the c value to count to these points, and then we write down what they are. The next one, this one is a hyperbola because it's in that fraction format. It looks just like the ellipse, except there's a minus sign in between. The center, again, x is with x and y is with y, so this one is going to be a negative 2, 3 for my center. And the next things I'm going to fill in the a and the b. Again, a squared comes first and then b squared, so a is a 3. That is a little bit ugly looking. Let me try again. It's a 3. The b value is a 5. And now from here, I'm going to plot this whole thing, and then I'm going to label the vertices and the focal points. All right? So I start with negative 2, 3. That's my center. The a squared is underneath the x, so I'm going to count left and right according to a. So I go to the left 3 and to the right 3. And the a value gives me my vertices. So the points that I just plotted, these are the vertices of this thing. And maybe I should color coordinate this like I have been doing. So if I draw those in purple, so the vertices here, that's going to be, it looks like one of them is a negative 5, 3. And the other one is a 1, 3. Okay, the a value allows me to plot those, just like the c value allows me to plot the focal points. And now from here, the b value counts up and down, so I go up 5 and down 5. I'll go the down 5 first and then up. Out there. And instead of connecting these with a circular type of pattern like an ellipse, I connect them with a box. Okay, so I make this box which ends up being a dotted line. So a box that's as tall as the b value and as wide as the a value this time. And now from here I connect the corners of this box. These are my asymptotes. Again, these are dotted lines. And these asymptotes are basically going to determine the shape of this thing because they determine how wide or narrow this is going to be. Okay, so I have my asymptotes. And now from here, to draw the actual graph of this thing, I start at the vertex and I hug that line. So I draw a curve that hugs the line. I start at the vertex and I draw a curve that hugs the line. And that's it. All right, so I have this whole thing graphed. Now, in order to find the focus inside each of these curves, what I have to do is I use that's the formula for C, which in this case is going to be a squared plus b squared equals c squared. So that's going to be 9 plus 25 equals c squared, which is a 34 equals c squared. And now I take the square root of each side. That gives me about a 5.8. Again, technically it's plus or minus a 5.8. Keep that to one decimal place because you don't want it to be rounded off too much, or it might be on top of one of your vertices or something like that. But it's telling me to go 5.8 in each direction. So if I go 5.8 in one direction, puts me about here. If I go 5.8 in the other direction, puts me about here. And now I just label what those points are that I just graphed. And again, I was counting from the center. So one of those gives me, it looks like a negative 7.8, comma 3. And the other one looks like it gives me a 3.8, comma 3. And that's it. All right. So again, most of these things I'm pulling from the graph. I'm graphing them first and counting using the C values and the A values and the B values, and then writing down what they are. Okay? In these, I want to write each of these in standard form, and the first thing I should probably do is identify what kind of conic section I'm dealing with, because that's going to tell me where to stop in terms of doing my completing the square twice, and then whether I'm going to divide by the constant terms and things like that. So the first one here, when I look at the x squared and the y squared, so there's two squared terms, so it's not a parabola. So I look at the coefficients. Because I've got a 1 here and a 1 here, when the coefficients are the same on the squared terms, it means that I'm dealing with a circle. So this first one is a circle. The next one, I've got a positive 5 and a positive 4. When the squared terms have the same sign but different numbers, it means we're dealing with an ellipse. And then this next one, it's got an x squared and a y squared with coefficients of 2 and negative 4. When the signs are different, it means I'm dealing with a hyperbola. Okay? So now from here, when I'm dealing with a circle, I complete the square twice, but I don't divide by the constant term. So I'm going to complete the square twice. So I've got to create space. I'm going to subtract the 6 from each side. And I organize. I put my x's together and I put my y's together. Again, I'm creating a little bit of space. Now I complete the square, b divided by 2 and square it. That gives me a 16. For the next blank, I do b divided by 2 and square it, and it gives me a 9. Whatever I do to one side, I have to do the other side, so I have to add the 16 and the 9 to the other side. And now I factor this thing. This guy factors into an x plus 4 squared. This one factors into a y plus 3 squared. And over here, when I add all these up, it looks like it gives me a 36. And that's where I stop. Because this is a circle, it's just equal to r squared. I don't have to do anything else. In the next one, we're going to do the same thing essentially, except at the end we're going to have to divide by the constant term because it's an ellipse, so we need a 1 on one of those sides. So the first thing we do is create space. I'm going to add the 4 to each side. And I'm going to organize some things. So I've got the 5x squared plus the 30x with a little space. Put the y's together with a little space. And equals a negative 1. And now from here, I can't just go b divided by 2 and square it. I can only do that if I have a 1 in front of the squared term. So I have to factor out this 5. So I need a 1 out front. And I'm going to have to factor out this 4. So that I have a 1 out front. Now, inside of each of those parentheses, I can do b divided by 2 and square it. Here that gives me a 9. Here that gives me a 4. And I have to add the same thing to the other side, but keep in mind, this first guy, this isn't just a 9. It's a 9 that's being multiplied. I would distribute this 5. It's a 9 that's being multiplied by a 5. So I added a 9 in the parentheses, but I added a 45 to that whole side. The next one, I added a 4 in the parentheses, but I added a 16 to the whole side. And so now when I simplify this, so I'm factoring each of these. Over here, it leaves me with a 60. And now I have to turn that into a 1, so I divide each side by 60. And so what I do is I divide each piece, so I reduce each of these. That gives me a 12. Sorry, that is a minus sign. When I reduce this one, it's going to give me a 15 in the denominator. And this isn't quite done because this is an ellipse. Remember, with an ellipse, the a value, the first denominator, has to be larger than the second denominator. So I just need to rewrite this and put the first fraction, or the second fraction first, and the first fraction second. Okay, so I have to switch places with these two fractions so that it's completely written in the right format for my ellipse. Okay? The next one, the hyperbola, is almost identical to what we did with the ellipse, except at the end we don't have to have the larger denominator first. The negative sign will determine the order of this thing. So I still start off the same way. I create space. I organize everything, putting the x's together and the y's together. I can't complete the square unless I have a 1 out front, so I factor. Here I have to factor out a -4, so just be careful with your signs here. That leaves me with a plus 2y. And now I fill in the blank. B divided by 2 and square it here gives me a 25. Here it gives me a plus 1. But that first thing, that's not just a 25, it's a 25 times 2, so it's actually a 50. The next one's not just a 1, it's a 1 times -4, so it's a -4. Okay? And so what happens here is I end up with the 2. This factors into an x plus 5 squared. This one, the -4, this factors into an a y plus 1 squared. Over here I'm left with a 52, and now I've got to divide each side by the 52. And when I do that, if I can write it over here a little bit, I get the x plus 5 squared over a 26 minus, that's going to be a y plus 1 squared over a 13 equals a 1. Okay? And so again, we take the same approach as we did with the ellipse, even dividing at the end, but it's important to understand what kind of conic section we're dealing with. That'll tell us whether or not we need to switch the order of these fractions based on the size of the number. It'll tell us whether or not we even need to divide by the constant term. Okay? If I look at these next couple, it says to write the equation of each conic section. For this one, it says the parabola with focus 6, -1 and directrix of x equals 4. The best way to approach this one is going to be by graphing, because there's basically two things I need here. I need the vertex, and I need the a value in order to write the equation of this thing. All right, so I'm going to just draw a graph. So let's see, I've got 1, 2, 3, 4, 5, 6, -1. That's my first piece of this graph. And then I have x equals a 4, which is a vertical line right here at 4. And so if this is my focus and my directrix, I know that the parabola has to pass exactly halfway in between those two. So the vertex for my parabola has to be right here. It's got to be exactly halfway in between that point and that line. And so my vertex is the ordered pair 5, -1. From here, the a value, remember, is directly associated with the focal length. So right here, the distance between the vertex and the focus right here is a 1. That's my focal length, all right? So the focal length is 1, which means 1 over 4a equals 1. Well, now I just have to solve this for a. I cross multiply, I divide by the 4, and I find out that a equals a 1/4. And keep in mind that you might have to change this to a negative if for some reason this is opening to the left or it's opening down. This one's opening to the right, so the a value has to be positive anyway. And since this is a horizontal parabola, when I actually graph this, I should see that it's opening in this direction, so it's horizontal. So it's going to be an x equals equation, so it's x equals a times y minus k, which is a -1, so that's plus 1 squared, plus h, which is the 5. And that's it. So I find the vertex, find the a value, I plug it in. The next one, the circle with endpoints of the diameter 0, 3, and 6, -5. So remember, I need the center and I need the radius this time. The center is always just the midpoint. The midpoint is essentially the average. So I add the x's together and divide by 2. And then I add the y's together and divide by 2. So for the first piece of my ordered pair, I get a 3. The second piece of my ordered pair, when I add those together and divide by 2, I get a -1. All right. And then from here, the radius is the distance from the center to one of the endpoints. So you can either spread these out, think about where these ordered pairs are and set up your Pythagorean theorem, or use your distance formula. The distance formula, you subtract the x values, so you would do 3 minus, I'm just going to use that first ordered pair, 3 minus 0 and square it, plus subtract the y values, -1 minus 3 and square it. And so what you end up with here for the distance, you get 3 squared, which is 9, plus, in here you get -4 squared, which is 16. So you get the square root of 25. So you find out that the distance here is 5, so the radius is 5. Well, now I just plug it into the equation for my circle. Remember with a circle, I do x minus h squared plus y minus k, which is going to end up being a +1 squared, equals r squared, which is 25. Okay? Find the center, find the radius, plug it in. In this one, the ellipse is really the same thing as a circle, except I have 2 different radii. So I'm going to find the center, and I'm going to find the first radius and the second radius. The center is still the midpoint, so I add together and divide by 2, and that gives me a 6. If I add the 10 and the -4 together and divide by 2, that's going to give me a 3. And now the a value is the radius of the major axis. Well, right here, because the 6 is the same, I can see that the distance between these two is actually 14 units, which means my radius is a 7. That's the a value. And then what happens here is the focal points don't give me a or b. The minor would give me b. These are actually going to give me c, but I do the same thing. If I look at the distance between these two, the distance here is 10, which means my c value is a 5. It's the radius. And now I use my formula, a squared minus b squared equals c squared. This is the formula for finding the focal length, but now I'm just going to use it in reverse to find b. So I get 7 squared, which is 49, minus b squared equals c squared, which is 25. And now from here, I just have to solve this. So I subtract the 49 from each side. I guess I'll show my work here. So I get a -24. And now from here, I just have to divide by the -1. So I end up with b squared equals 24. I take the square root of each side. And I'm not even going to simplify this square root. I'm just going to leave it as the square root of 24. Because what happens when I go to plug this into my formula, I'm going to square that anyway. So for this one, again, I want to think about where these ordered pairs are. If I think about the major axis at 6, 10, and then 6, -4, I can see that the major axis runs up and down. So this is a vertical ellipse. So I'm going to do y minus k squared over a squared plus, because it's an ellipse, x minus h squared over b squared, which is the 24, equals 1. Okay? The next one is almost exactly the same as the ellipse. The hyperbola, the only difference here is instead of a major and a minor axis, we have a transverse and a conjugate axis. And right here, the vertices, these are the endpoints of the transverse axis. Okay, so these are going to help us find A. And then the length of the conjugate, that's associated with the B value. But the center is still the same thing. The center is the midpoint of these. So I add those x's together and divide by 2, and that gives me a 3. Add the x together, divide by 2, gives me a 1. So I get a center of 3, 1. And now the A value, again, if I look at the distance right here, these are the endpoints of the transverse axis. The distance between these two looks like 16 units, which means the A value is the radius of that. It's 8. And then here, the conjugate axis says right here that it's 10 units long. That's a diameter, so the radius, the B value, is 5. And now, just like with the ellipse, I'm going to determine which way this thing is supposed to be going based on where the vertices are. So if I just think about where the vertices are 11, 1 or negative 5, 1. I can see that the vertices are directly across from one another. They're to the left and right of one another. So this one is horizontal. So I do x minus h squared over a squared minus y minus k squared over b squared equals 1. And that's it. Okay, so for the ellipse and the hyperbola, let's find the center, find the a value, find the b value, plug it in. All right? In this last piece, identifying conic sections, is really all about the squared terms. Remember, if you only have one squared term, either an x squared or a y squared, it's a parabola. All right? Then if there's two squared terms, we look at the coefficients. If they have the exact same coefficients, it's a circle. If the coefficients have the same sign, but they're not the exact same number, it's an ellipse. And if the coefficients have different signs, if one's positive, one's negative, then it's a hyperbola. All right? So if I look at the first one, I've got two squared terms, the 3x squared and the negative 8x squared. So two squared terms, it's not a parabola. So I look at the coefficients. Well, the coefficients, one's positive, one's negative, they have different signs. So this one is a hyperbola. All right? The next one, again, there's two squared terms. So I look at the coefficients. One is a positive 1, the other is a positive 3. They have the same sign, but not the same number. That means it's an ellipse. All right? The next one, I look at the squared terms again. Here I've got two of them again. The coefficients are each a positive 4, so since it has the exact same coefficients, it's a circle. And then the last one, there is only one squared term. Only an x squared, there is no y squared, only one squared term indicates that this thing is a parabola. All right. So again, you're working through your different conic sections. Remember that there's a different equation for focal length with each one. Parabola is 1 over 4a. The ellipse is a squared minus b squared equals c squared. And the hyperbola is a squared plus b squared equals c squared. And then determining the differences between them. It's all about these squared terms, okay? So just be aware of the different formulas and how each piece is going to be used. And be especially aware of whether it's vertical or horizontal for each of these, okay?